Hi, Myklen. You sent me an email asking me about a specific sort of problem that you're having trouble on. So what I wanted to do is actually just run through the problem with you on a video here so you can see how that problem works. So you're basically what you're asking to do in this problem is basically determine whether or not this statement is a tautology, is it a logical contradiction, is it contingent, consistent, that sort of thing. So let me write out the problem here. It's Q. If Q, then not C. And if R, then not Q. Okay. Now, in terms of what you had to do on the test was determine whether or not it's a tautology, whether or not it's inconsistent, self-contradictory, contingent, or consistent. Okay. Now, the first thing to know is since we're not actually comparing two statements. This is just one single statement. And so that means that we're not actually going to be comparing statements. This is what we're going to be doing is classifying statements, which means that we're not going to be talking about consistency or inconsistency. What we're really talking about is whether or not it's a tautology, a self-contradiction, or whether or not it's contingent. Okay. Now the first thing you need to do is determine how many lines. Right. This is the first thing to figure out is how many lines of the truth table do you need to construct. Now, in order to do that, figure out how many unique variables do you have. Well, I have a Q, that's the first unique variable. I have a C, and then I have an R, which means I have three different variables. Now, the formula, right, for determining how many lines is this, 2n, where n signifies the number of unique variables. We have 2 to the third, and that's equal to 8, which means these need to be 8 lines long. Okay, so let's do it real fast. So that's going to be T, 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 F, 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 F. Okay, so those are the first 8 variables. Now I need to make sure that they're the same under the Q on this side too. So I'm just going to fill those in as well. That's going to be the first 4 are true, and the second 4 are going to be false. Okay, now I'm going to move over to the C. And remember, what I'm going to do is I'm just going to go true, true, false, false, true, true, false, false for this C. For it falls under C. That's true, true, false, false, true, true, false, false. Now let's do R, which is going to be true, false, true, false. That's true, false, true, false, true, false, true, false. Okay, so now I've done that. So the first thing I need to do is then just work through the problem. And since let's start over here on this side, so that means these are going to turn. This is going to turn to false, false, true, true, false, false, true, true, right? And now you're going to be doing these. So and you're using the rule here of the conditional, which means it's going to be true in every case unless it's the antecedent is true and the consequent is false, like in this first case. So that's going to be false, false, true, 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 true. Okay? Now let's move over here to this line. Okay? We're going to do the Q. And then we're just going to basically invert the values. So that's going to be false, 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 true, 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 true. Okay, now I'm going to use that. I'm going to be comparing this row and this row utilizing, again, the same conditional rule I did over here. So that's going to be false, true, false, true, true. Whoops. Okay, that's going to be true, true, true. Okay. Okay, now this is where it's helpful. By the way, a lot of times it may be helpful to actually have a highlighter because I'm going to compare this row and this row utilizing the rule of conjunction here. Now, the rule of conjunction says they both have to be true in order for it to be true. This is the strictest rule. And I'm going to put this in green just so that way you can tell the difference here. False, anything that's false has to be false under the rule of the conditional. This is going to be false, that's false. That's false. Okay, so that's the first 3. The second one here is true. I'm sorry, the fourth is true, and then this is true, 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 true. Okay, so the rest of them are true. Now, okay, that means that you can see here, if it was a tautology, then that would mean that it would all be true, and that's not the case. It's not self-contradictory, because in order for it to be self-contradictory, it has to all be false, which means that this problem has to be consistent. Okay, that's going to be the right answer here. It's got to be not consistent. I'm sorry, contingent. Right? This is a contingent statement. And what is it contingent upon? It's contingent upon whether or not these things are actually true or false. Because you can see in a number of cases, this statement would be true, but there's 3 possibilities in which it's false. So it's contingent upon whether or not whether or not the truth values actually accord with one of these 3 lines, or whether or not they fall down here. Okay, so that's how you do this problem, and hopefully this gives you a better sense, as well as anyone else who's having trouble with this. Okay, I'll talk to you guys later. If you have any questions about this problem, or you want me to do another problem, feel free to send me an email with another example problem. Okay, I'll talk to you guys later. Bye.